Here are the solutions to the conic sections review. Please make sure that you have tried the entire review, looking back at your notes and the previous lessons I posted before you just go straight to looking at these answers. So for the first page, actually up through number 10, we had to first classify each conic section, write the equation in HK form if it's not already, sketch the graph. For each parabola, make sure you identify the vertex and the axis of symmetry. For circles, identify the center and radius. For ellipses, identify the center and the length of each axis, major and minor. And for hyperbolas, identify the center and the slopes of the asymptotes. All right, so starting off with number 1. Again, I posted just the answers on Friday, so this is just showing each step-by-step process for each problem. All right, for number 1, if you notice, we only have a y squared, not both an x and a y squared, so this will graph a parabola. Looking because it's going to be solved for x because the y is square, this is going to be a sideways parabola. So we want to get the x by itself and get all the other terms to the other side. So I'm first going to just leave the x over here on the left side. I'm going to move every term over to the right. So we'll now end up with a positive 2y squared plus a 4y minus 1. To complete the square, I'm just looking at the first two terms. I'm going to factor out a 2. We're going to be left with a y squared plus a 2y. Leave a little bit of space to complete the square. Half of 2 is 1. 1 squared is 1, so I'm going to add a 1, but really I'm adding a 1 times 2, so I'm adding a 2 to this side, which means I need to subtract a 2 as well. So now I'm going to end up with 2. We're going to factor this as y plus 1, that quantity squared, and negative 1 minus 2 at the end is going to give us a minus 3. So this is the HK form. Remember, for sideways parabolas, it's x is equal to a times the quantity y, minus k squared, and then plus h. So over here, this minus 3, that's our h. The 1 is our k, or actually it's going to be a negative 1. So our vertex is at negative 3. Remember, it's always h then k for the vertex, the ordered pair of the vertex. So we're going to have negative 3, negative 1 as our vertex. Our axis of symmetry, with this being a sideways parabola, our axis of symmetry is going to be horizontal. So that is going to be a y equals, and remember it's always y equals k, so y equals negative 1. And then we'll go ahead and graph this. So each one of these are counting as 1, so I'm going to go 3 to the left, 1 down. Now a is 2, so this is going to open to the right. So now instead of counting over and up, I'm counting up and over. So if I count up 1, since a is 2, I'm going to double 1 squared. So if I count up 1, I'm counting to the right 2, down 1 to the right 2. If I go back to the vertex, I count up 2. 2 squared is 4. I want to double that, so I'm going to count right to the right 8. Same thing down here, 2 down and then 8 to the right. And then that's enough to draw our parabola. And again, remember, you can graph this on Desmos just to double check. And again, our axis of symmetry is right here, a horizontal line at y equals negative 1. All right, looking at number 2, we see both an x and a y squared. They're on the same side of the equal sign. If you notice, one has a negative coefficient, one has a positive coefficient. That makes this a hyperbola. And we need to rearrange the order. We want the positive term to go first, so I'm going to write this as y squared. Notice I have no other y terms, so next I'm going to put the minus 25x squared minus the 100x, and then I want to get that 125 to the other side. So there's nothing to factor out of the y squared, but the minus 25x squared minus 100x, I'm going to factor out a negative 25, so our signs are going to change. So I'm going to get an x squared and then plus a 4x, because negative 25 times x squared will give me the negative 25x squared. Negative 25 times a positive 4x will give me my minus 100x. Leave a little bit of space to complete the square, and then I'll have the 125 on the other side. All right, so half of 4 is 2. 2 squared is 4. But I'm really adding a 4 times a negative 25. So I'm really adding a negative 100. So I'm going to add or subtract 100, add a negative 100 or subtract a 100 from this side. So now this turns into y squared minus 25 times the quantity x plus 2 squared equals 25. Remember, the HK form of a hyperbola is I need to see two fractions being subtracted and it needs to equal a 1. So my next step is to get that number on the right to be a 1. I want to divide everything up here by 25. So now my equation becomes y squared over 25 minus the quantity x plus 2 squared. This will just become a 1, but I'm still going to write it over a 1 so it's easier to work with, and then equals 1. So my center, remember, x and h always are together, so this is my h, my k is over here, which is really a 0. So my center is at negative 2, 0. The slopes of the asymptotes, remember, a squared and b squared always stay in the denominators. A squared of a hyperbola is always first, and then b squared is always second. So I'm just going to write this off to the side. Remember, in this case, I'm going to write it as y minus k squared over a squared, since my y squared is first, minus my x minus h squared over b squared equals 1. So a squared is 25, b squared is 1, so a is 5, and b is 1. So my slope is, remember, it's whatever is underneath the y squared, that's the numerator, that's my rise. So it's going to be plus or minus a over b here, so I get plus or minus 5 over 1. And because y squared is first in the numerator, this is going to be a north-south hyperbola. So I'm going to go to my center at negative 2, 0. I'm going to count using my slopes of the asymptotes here. I'm going to count up 5 and over 1 to either side, and then down 5 over 1 to either side. This is where I draw the rectangle. And then I'm going to draw the diagonals here for the asymptotes. All right, so because this is north-south, we are going to put each vertex. Now notice here I wasn't asking for the vertex, but still know what it is. So I have a vertex right here at the top and the bottom right in the middle. And because this is north-south, it's a nice skinny hyperbola to draw. I know the wider ones are a little bit tougher. But we have one here, and we have our other one down here. All right, so for this, we were just asked to identify the center and the slopes of the asymptotes, which we have right here, and then our graph as well. All right, looking at 3, notice we have an x squared and a y squared. They're both on the same side of the equal sign. They both have the same exact coefficients. They're both a positive 1, so this makes this conic section a circle. To complete the square to get this in HK form, I'm just going to put the x terms together, then the y terms together, and that negative 9 is already on the other side. So now I just want to complete the square twice. So we're going to have x squared plus 8x. Half of 8 is 4. 4 squared is 16. And then plus y squared minus 6y. Half of 6 is 3. 3 squared is 9. So I'm adding to this negative 9 that was already on the right side, I'm adding a 16 and then a 9. So for this part, I'm going to factor into the quantity x plus 4 squared. And then for the second one, the quantity y minus 3 squared. And then the 9's cancel out, and we're left with the 16. So remember, the equation for a circle is going to be x minus h squared plus the quantity y minus k squared equals r squared. So my center is at negative 4, positive 3, and my radius is the square root of 16, which is 4. So for each circle, we just identify the center and the radius. Pretty simple to graph now. We're going to go 4 to the left and 3 up. And from this, I'm counting 4 up in each, or 4 up, 4 down, 4 to the left, and then 4 to the right. And there's our circle. All right, so I hope you guys are doing good so far with these. All right, for number 4, it's a little bit nicer. This is already in HK form. It is a parabola because only the x is squared, not both the x and the y. And remember, this is because it's the x that's square, this is going to be a parabola. In this case, that opens up. Because remember, the HK form is y equals a times the quantity x minus h squared plus k. Well, because we don't see the parentheses, this means h is 0 and a is 1. So really, we could take this and write this as y equals x minus 0 squared minus 6. So this gives us a vertex at 0, negative 6. We already said it's going to open up. A is 1. And then the axis of symmetry. Since this is a parabola that opens up, our axis of symmetry is vertical, so it's going to be x equals 0. So if I go to 0, negative 6, a is 1, so if I count over 1, I'm counting up 1 squared on either side. Go back to the vertex, count over 2. 2 squared is 4 on either side, and we have enough of points. And there's our parabola. Again, here's our axis of symmetry, a vertical line, x equals 0. All right, for number 5. Hopefully you guys are saying this is an ellipse because x squared and y squared both show up. They're both on the same side of the equal sign, and they both have positive coefficients, but they're different. So this is an ellipse. If they were the same, both 9s or both 4s, it would be a circle. All right, so to complete this square, I'm going to get the x's to go first. Because remember, with an ellipse, I'm just going to write this down at the bottom here. It's always x that goes first, so it's x minus h squared over a squared, and then plus y minus k squared over b squared equals 1. But it's the a squared and b squared that can switch. Whatever is larger is the a squared. So I'm not sure right now until I get this in HK form. So we'll have 9x squared minus 54x plus 4y squared minus 8y. We'll take the 59 to the other side. So for the first two terms, I'm going to factor out a 9. We'll have x squared. 9 times 6 is 54. So minus 6x, leave a little bit of space to complete the square. The next two terms, I want to factor out a 4. Then we'll have y squared minus 2y, leave a little bit of space to complete the square, and then equals 59. So inside here, half of 6 is 3. 3 squared is 9, but I'm really adding an 81. So I'll add an 81 to the other side. And then inside with the y's, half of 2 is 1. 1 squared is 1, but I'm really adding a 4. All right, so now factoring this, we'll get 9 times the quantity x minus 3 squared plus 4 times the quantity y minus 1 squared. Couple ways you could do this. You could add the 81 and 4. You can get 85. 85 minus 59. Oh, I'm sorry, that's all positive. So 85 plus 59 is going to give us 144. All right, next we want to just divide everything up here by 144. Because again, we still want to get that equal to a 1. Now this is a case we should have been more commonly expecting a 36 because 9 times 4 is 36, but it's okay. As long as 9 and 4 go into 144, it's still possible to do this quite simply. So 9 goes into 144 16 times. And again, you can use a calculator to figure that out. And then 144 divided by 4 is 36. So here we're going to get the quantity x minus 3 squared over 16 plus y minus 1 squared over 36 equals 1. So because the 36 is in our second denominator, that's a squared. So a is 6. B squared is 16, so b is 4. So because the 36, the a squared is our second denominator, this is going to be an ellipse where the major axis runs vertically. So it's going to sort of stand up taller than be horizontal here. So our center, our h is going to be our 3 and our k is going to be 1. So our center is at 3, 1. And then we'll go ahead and graph this. So going over to 3, 1, there's our center. Again, because A is 6 and this is vertically longer than it is horizontally, I'm counting up 6 and down 6. And then across, I'm going to count 4 to the right and 4 to the left. We'll go ahead and draw that in. All right, so for this, we have our center. Now our major axis, remember, our major axis runs from the center, and we go A units up, which is 6, and another A units down, another 6 units down. So it's going to be a length of 12. Always make sure, because it is a length, we put units. And then our minor axis is sort of the shorter diameter. So we're going 4 to the right and 4 to the left, so that's going to be 8 units. All right, so there is number 5. All right, looking at 6, again, we see an x squared and a y squared on the same side. One's negative, one has a negative coefficient, the other has a positive, so this is like number 2. This is a hyperbola. Only here, I want to rearrange this. I want the 25y squared to go first. We'll have 25y squared minus 100y, then minus 9x squared, and we'll move the 125 to the other side. So first I need to factor out a 25 only from the first 2 terms. This will give me a y squared minus a 4y. Leave a little bit of space to complete the square. Notice there's no other x terms, so nothing to factor out here. So what are we going to add? Half of 4 is 2. 2 squared is 4. But I take the 4, multiply it by 25, so I'm really adding a 100 here. So we're going to get 25 times the quantity y minus 2 squared minus 9x squared equals 225. Now actually 25 times 9 is 225. So we'll divide now everything up here by 225. So this will become y minus 2 squared over 9 minus x squared over 25 equals 1. So since this is a hyperbola, we're looking not at the denominators but the numerators. So this is going to be another north-south because the y is first, just like number 2. It's going to be a north-south hyperbola. The center, again, h is over here with the x, k is over here with the y. So because there's no number, there's no set of parentheses here, h is 0, and then k is 2. All right, so a squared is 9, which means a is 3, b squared is 25, so b is 5. So the slopes of our asymptotes are plus or minus. Remember, it's whatever's under the y over whatever's under the x. So it's going to be plus or minus 3/5. So putting our center at 0, 2, I'm going to count up 3 over 5. Down 3 over 5. Draw a rectangle. Not that. And then draw on our diagonals, our asymptotes here. All right, so one vertex, again, it's north-south, is going to sit on in the middle of the top side of the rectangle. The other one's going to sit in the middle of the bottom side. And then try again, just to draw this as best you can. Again, I don't want to see anything that looks like this. Take your time and draw it accurately. Stick to the sides of the asymptotes, touch the vertex, and then go to the other asymptote. All right, so here is our graph for number 6. Again, we have the slopes of the asymptote stated along with the center. Again, you can check on Desmos. All right, looking at 7, we see an x squared, not both x squared and y squared, so that makes this a parabola. because it's the x squared, this is going to be a parabola that either opens up or down. So let's get the y by itself. Let's move everything else to the other side. So we're going to get a negative x squared minus a 10x minus 26. So I'm going to factor out a negative from this. Remember, we can only complete the square when our leading coefficient is a positive 1. So now I'm going to write this as y equals negative x squared. This will become a plus 10x. We'll leave some space to complete the square, and minus 26. Half of 10 is 5. 5 squared is 25. But I really added a negative 25 to this side. So to balance it out, I need to put a plus 25 over here. All right, so next we're going to have y equals, leave that negative out in front, it becomes the quantity x plus 5 squared. Negative 26 plus 25 is a negative 1. So remember, side or a parabola that opens up or down is going to be y equals a times x minus h squared plus k. So h is the the negative 5, and then k will be our negative 1. So our vertex is at negative 5, negative 1. Axis symmetry is going to be x equals, it's a vertical line, so x equals negative 5. So these are the two parts we needed to answer here. A is negative 1, so our parabola is going to open down. All right, so going to our vertex at negative 5, negative 1. If I count over 1 to the right, I'm counting down. Over 1 to the left, counting down 1. Over 2 from the vertex to the right, I'm counting down 4. Over 2 to the left here, counting down 4. So we have enough points to draw our parabola. And again, our axis of symmetry matches. I could draw a little straighter. Okay, matches the line x equals negative 5. All right, for number 8. All right, notice we don't have both x squared and y squared on the same side, so I'm going to move some things around. As soon as I do bring the y squared over, it's also going to be positive. So I have x squared minus 2x. I'll put the y squared in next. Minus 10y equals negative 17. So since they both have the same positive 1 as a coefficient, this is going to be a circle. And we'll complete the square. Nothing to factor out in front, so this just becomes x squared minus 2x. We'll start to complete the square. Half of 2 is 1. 1 squared is 1. And then y squared minus 10y. We're going to add a 25 here. Half of 10 is 5. 5 squared is 25. So to this negative 17, we're adding a 1. And then we're going to add a 25. So here I'm going to get the quantity x minus 1 squared. Plus then the quantity y minus 5 squared. We could look at this as negative 17 and then plus 26, so we're going to get a 9. And then that's it for the circle. We don't have to divide by anything. Here our center, h is in with the x, so we're going to get a 1, 5 for our center. Radius is the square root of 9, so the radius is 3. So for my center, I'm counting over 1, up 5. And I'm going to count 3 in each direction, 3 to the right, 3 up, 3 to the left, and then 3 down. And there's our circle. All right, what's a little bit nicer about the last two is that they are already in HK form. So if you notice for number 9, we have two fractions being added together equaling a 1. So right away, this tells us this is an ellipse. Now remember, for an ellipse, it's not where the x and y are, it's where the a squared and b squared are. So in this case, the larger denominator is 16. So this tells me a squared is 16. And since that is the first denominator, we have an ellipse that's longer horizontally than it is vertically. So a is going to be 4, b squared is 4, so b is going to equal 2. My center, again, h goes with the x, k goes with the y, so we're at a negative 5 and a positive 2 for our center. So let's go ahead and graph that. So negative 5, 2 puts us right here. Since a is 4, that means I'm counting right and left 4. And then b is 2, so I'm counting up 2 and down 2. So there is my ellipse. So we also need the length of a major axis. Major axis, I would be counting from the center, 4 to the right, 4 to the left, so we have a length of 8 units. And then the minor axis, I'm counting 2 up and 2 down, so I have a length of 4 units. All right, so again, for each ellipse, we're identifying the center and the length of each axis. All right, number 10 was the last of this first set of problems here. This is also a parabola. Seen a couple of these. Again, because only the y is squared, not both x and y. This is a parabola. It's already in HK form, because remember, going back to this, it's x equals a times the quantity y minus k squared plus h. So this tells me h is over here, because we could write this x equals negative y minus 0 squared when there's no set of parentheses here plus 2. All right, so h is going to be the 2 and k is going to be 0. So my vertex is at 2, 0. My axis of symmetry, since this is a sideways parabola and because a is a negative 1, this is going to open to the left. So my axis of symmetry is a horizontal line. It's y equals k, so y equals 0. So I'm going to go ahead and plot my vertex at 2, 0. When I count up 1, I'm counting to the left 1, or down 1 to the left 1. Up 2, 2 squared is 4, so I count to the left 4, down 2, count 4 to the left, and then there's my parabola. Again, drawing in the axis of symmetry is right here at y equals 0. All right, so please let me know by email if you guys have any questions on these 10 problems. The next 3, we are looking at a graph we're given, and we have to write the equation. All right, so for number 11, this is a sideways parabola. It's opening to the right, so it's going to fit this form, x equals a times the quantity y minus k squared plus h. So first we need the vertex. So the vertex is right here at 1, 2, and then we need a. So if I count up 1, I'm counting over 1. So a is just a positive 1 because we're opening to the right. So to fill this in, it's going to become x equals positive 1, which I don't need to write, y minus k. So here's our h and our k, so it's y minus 2. Don't forget the exponent of the square there, and then plus the 1. So our equation is x equals a quantity y minus 2 squared plus 1. All right, for 12, we have an ellipse here. Our center is right here at negative 1, negative 3. Then we count for a. Now, this is longer vertically than it is horizontally, so a is 3. And then b is going to be 2. And that's all we really need, because now when we go to fill this in, we have 2 fractions being added together equaling a 1. Our center, remember with an ellipse, x is always a first numerator, so this is going to become x minus a negative 1, or x plus 1 squared. And then we'll have y minus a negative 3, or y plus 3 squared, because this was our h, this was our k. And because it's longer vertically, a squared goes second, so 3 squared, or 9, will go in our second denominator, and then 2 squared, which is 4, goes for our first denominator. So here is the equation. Remember, once you have your equation written out, you can type it in on Desmos and see that it graphs this ellipse that we had in front of us. All right, number 13 is a hyperbola, so a couple things we need here. We need the center, which is right here at 0, negative 3. And then we need the slopes of the asymptotes here. So if I count up 2 and then 3 to the right, so it's plus or minus 2 over 3. So here we need 2 fractions being subtracted. That's going to equal a 1. Now this is an east-west hyperbola, so that means x squared is going to go first, and h is 0 k is -3. So when I go to write x minus 0 squared, I don't really need the 0, so it's going to be x squared, and then we'll have y minus a -3, so this becomes y plus 3, that quantity squared. So remember, the numerator here, that value squared is going to go underneath the y. So we're actually going to have 2 squared, which is 4, underneath the fraction containing the y. And then 3 squared, which is 9, will go underneath the x squared. So here's our equation for this hyperbola. All right, for number 14, it says write the equation of a circle that is tangent to the line y equals -4. So I'm going to first graph the line y equals -4. So it's a horizontal line going through -4. So here's my line, y equals -4. And we're also given the fact that this circle has a center at 3, 0. So that means that this circle needs to touch directly right down here. So if I have a center at 3, 0, this is going to help me determine my radius, because right now I have a circle that it will go like this right here. So I have a radius of 4. So that's all we really need. I didn't have to draw the entire circle. So to write this out, it's going to be x minus k, or h, so x minus 3 squared, plus y minus k squared, which is y minus 0, so it's really just a y squared, equals r squared. My radius squared will give me 16. So this is the equation of this circle. Now number 15, I know at the very beginning I had you guys look up different images, real life images of conic sections. So please just be able to do that. For instances, here we looked at the St. Louis Arch as an example of a parabola. We said, and again, to kind of leave out circles, we know what common shapes of circles are. We had the ceiling of a whispering room. Was an ellipse. The smokestacks of a nuclear power plant. Was a hyperbola. What I also liked, a good example of a hyperbola, it wasn't a lampshade itself, but it's the light on a wall above and below the lampshade. Other examples of parabolas were like the arches in a roller coaster ride, some bridges supports, so like part of the Eiffel Tower, not the entire Eiffel Tower, but at the base of it, the arches that were there. So these are just some good examples, the way that you can word them if I do ask you on any upcoming assessment. So please, I hope that you guys have taken the time to look through this video. Email me, as always, with any questions. Enjoy the rest of this week and have a nice Easter and spring break. Stay healthy.